Now, one of the things that distinguishes a class like geometry, honors geometry in particular, from the classes that come before it, algebra, and then the pre-algebra classes like 7th and 8th grade math, is the fact that the equations are not always explicitly given to you like they are on, let's say, questions 62 through 65. I don't mean to say that every single problem is going to be a word problem. It's just that usually you're going to have to make your own equation first and then solve that equation by whatever method is the most convenient. So let's look at 66 and 67 because that's essentially what you have to do. These are systems of equations. However, they're not given to you explicitly. You have to make it yourself. So you need to define some variables and then make some equations and then pick a method to solve it. So let's look at 66. The difference of two integers is 36. Integers are whole numbers, could be either positive or negative, and then difference, of course, means that we are going to subtract those two things. And if we're going to subtract them, and we're going to get 36, it's going to be the big one minus the small one. So I might just define my variables like x equals big integer, big number, and then y is equal to small number. As far as the variables go, it's kind of personal preference. You don't have to use x's and y's. You can use whatever you want to. And the first sentence here tells us what our first equation is going to be. The difference between these two, I'm going to subtract them, and I'm going to get 36 is equal. So I'd have x and then minus y is equal to 36. And now there's nothing that you can do with just this equation here. And the reason why is because there's an infinite number of things that when you subtract them, you get an answer of 36. And that's not what we want. We want just a single set of things, x and y, that's going to be 36. And that's where we're going to have to come up with a second equation. So let's look at the rest of the problem. The larger one is 13 less than 8 times the smaller one. All right, so remember we said that the big one is x and the small one is the y, and just follow the logic of the sentence here in order to write your equation. The larger one is x, so I would say x, the larger one is, that's equal to 13 less, so that means I have to subtract 13 from something. It's less by 13. 8 times the smaller one. The smaller one is y, so it's 8y, and then it has to be 13 less than that, so we're going to take away the 13 from that. And so that's the kind of process that I'd want to go through in order to write my system of equations. Define some sort of variables, translate the English of the sentences into equations, and then now I need to go back and try to figure out, is substitution or is elimination or even graphing the best way to solve that in order to find my solutions. And whenever you're all done with this, just check to see if it makes sense. Is it reasonable with the sentences that they give you? Let's look at 67. 67, much more geometric kind of problem. The perimeter of a square is 4 more than the perimeter of an equilateral triangle. If the sum of their perimeters is 76 centimeters, what is the side length of each shape? So I'm going to sketch a couple of pictures here. So starting with a square, all of the sides are exactly the same. What a weird looking square. I'm going to start fresh. Oh, now it's perfect. Pick a variable. It's a square, so I'm going to use s. S is usually a terrible variable to use in an equation because it looks sort of like a 5, but it's whatever. And my perimeter here is 4 of those things, 4 s's. Just make it fancy. Put a little fancy serif on the bottom and it won't look like a 5. And now I need myself an equilateral triangle. Again, all the sides are exactly the same. Different variable, not necessarily the same side length. This is triangle, so I'm going to use a t. Again, t is a terrible variable to use because it looks like a plus sign sometimes. So again, I make it fancy by putting a little serif on the bottom. And now this perimeter, well, we've got 3 of these, 3 t's. Okay. Now, You cannot solve what we have here because really there's more than just two variables. This p and this p, they're not the same perimeter. So even though I used p on it, it's more like this one is a p sub square and this is a p sub triangle on this one. So in total, that is a 1, a 2, a 3, a 4 different variables with 2 equations. Now you don't have enough information. Okay, so now you start dissecting the sentences, take the logic of the sentence, translate it into some mathematical equations. The perimeter of the square is 4 more than the perimeter of an equilateral triangle. So my perimeter of my square, that's 4s, is 4s, equal sign is 4 more than the perimeter of an equilateral triangle. So I'm going to take my equilateral triangle and have 4 more than that. So that's just 3t plus 4. So you can see how the t and the plus sign can get confusing. Anyway, without the serif. All right, again, I don't have enough information to solve this. You need another equation. So I need to look back at my original problem. If the sum of the perimeters is 76 centimeters, what's the side length? So even though this is not a full sentence, this is a fragment here. Actually, then you can dissect this. You got a subject and you have a verb and you have a predicate here. So it actually, this part here is a whole entire sentence. You can turn that into an equation. Sum of the perimeters. I'm going to take both of these perimeters here. I'm going to add them together. That's the sum. 4s plus 3t, and that should be equal to is 76. And now you have a system of equations that you can solve. It doesn't matter, it doesn't have x's and y's. You still follow the exact same kind of methodology here. And at this point, you need to decide, are you going to do substitution? Are you going to do elimination? Or are you just going to be straight up crazy and try to do graphing? That last part, make some sort of judgment call, solve both of these systems of equations, and let's see what you come up with.